In our previous lesson, we spent a long time talking about how to work with square roots. Things like square root of 16 equals 4, and so on. In this lesson, I'd like to push those ideas one step further. But before I can do that, let me just mention a different way to view square roots. Don't worry, the mathematics is still exactly what we learned in the earlier lesson. It's just that we need to understand a bit more about what is being asked of us when we're supposed to calculate a square root. So here's the idea. We know exactly what someone means when they say they want us to find 4 squared, or 4 raised to the 2 power. That's just 4 times 4, and that's equal to 16. No problem. And we also know what someone wants when they ask us for 5 raised to the 3, or 5 cubed, as some people say. That's exactly 5 times 5 times 5, which is 25 times 5, which is 125 once we go through the arithmetic. Hopefully that all makes sense. In other words, if you give me a number raised to a positive integer power, then I can figure out the problem with no trouble. But now, what happens if someone asks me for something like 5 raised to the negative 3 power, or 125 raised to the fraction 1/3? Now that could definitely be a problem because it's a very different kind of thing than what we've done up to this point. Well, it turns out that it's not all that different, and that we can handle both of the kinds of situations I just mentioned with no trouble. As usual, we just need to understand a couple of basic rules and follow those rules step by step and compute the answer in a systematic way. Really, honestly, it's straightforward once you get the hang of it. And remember, in mathematics, practice makes perfect, or at least really, really good. So at this stage of the lesson, I'd like to talk about raising numbers to a fraction power. We'll deal with those pesky negative exponents later in this lesson. But let's begin by talking about square roots again and thinking about powers or exponents with their fractions. So when I ask for the square root of 16, I'm asking for the number which, when squared, gives me 16. That means square root of 16 equals 4 because 4 raised to the 2 equals 16. Well, guess what? There's an alternate notation for square root of 16 which is just as valid and comes out of the idea that 4 raised to the 2 equals 16. Here it is. Square root of 16 is the same as taking 16 and raising it to the 1/2 power. In other words, 16 to the 1/2 is equal to 4 because 16 equals 4 to the 2. And honestly, that's all there is to it when we're looking at raising a number to the 1/2 power. So let me do a couple more examples involving 1/2 as the exponent. I want us to simplify 144 raised to the 1/2 power. Now remember, don't panic with this notation. It just means that we want to find square root of 144. And that means we just want to find a number which, when multiplied with itself, gives us 144. Well, you know the answer. It's a little bit larger than 10, of course, because 10 squared is 100, and that's not as big as 144. Well, what could it be? Well, it's not 11, because 11 squared is 11 times 11, which is 121. Still too small. What about 12? Well, 12 squared, or 12 to the 2, is equal to 12 times 12, which equals 144. If you've either memorized it, if you haven't, maybe you need to do some long multiplication. But bottom line, 12 times 12 is 144. And that's what we wanted. And so we know that 144 raised to the 1/2 power equals 12, because 12 raised to the 2 is 144. Now, again, sorry to focus on this so much, but knowing these basic arithmetic facts is going to help you tremendously in doing lots of these problems. So keep reviewing those facts as you walk through this course. Now, let's look at one more problem where the number that we're raising to is a 1/2 power. I want us to simplify negative 49 being raised to the 1/2 power. Now, again, as with the previous examples, When I say I want negative 49 raised to the 1/2, I'm saying the exact same thing as the square root of negative 49. That means I'm looking for a number which, when multiplied with itself, will give me negative 49. Now, think with me for a second. You might be tempted to say that the answer is 7, because 7 raised to the 2 is 7 times 7, which is 49. But you're missing the negative sign in front of that 49. Remember, we're trying to find negative 49 raised to the 1/2. So what would your next best guess be? Well, it would probably be negative 7 would be the answer. But that's also wrong, because negative 7 raised to the 2 is equal to negative 7 times negative 7, and that's equal to positive 49, which we learned in our previous lesson when we were multiplying two negative numbers. Anytime you multiply two negative numbers together, the negatives cancel each other out, if you will, and you get a positive answer. So negative 49 to the 1/2 power is also not equal to negative 7. Well, what is the answer? Well, the answer is that there's no answer. Seriously, within the real number system, which is the set of numbers we're working with in this course, there is no answer to negative 49 raised to the 1/2 power. In fact, we can say even more. There is no answer if you're asked to raise a negative number to the 1/2 power in the real number system. So, if I wanted negative 36 to the 1/2 power, I'd have no answer. And if I wanted negative 9 to the 1/2 power, that would make no sense as well. Okay, we've said quite a bit about numbers raised to the 1/2 power. Let's move forward to numbers raised to other positive fraction powers. So look at this example with me. I want to find 81 raised to the 1/4 power. All right, so before we get nervous about what this is saying, let's just realize this. Now we need a number which we can raise to the power of 4 to get 81 back. In other words, the answer times itself 4 times needs to give us 81. So now we have to think backwards again as we're trying to calculate 81 to the 1/4 power. Well, do you know such a number? Well, if you think about it for just a moment, think about the number 3 and raise 3 to the power of 4. Okay, let's see. That would be 3 times 3 times 3 times 3. So I'm multiplying 3 with itself 4 times. And 3 times 3 is 9. So it's the same as 9 times 3 times 3. Or 27 times 3. And 27 times 3 is 81. And that's what I wanted. And that work tells me that 81 raised to the 1/4 power is equal to 3, because 3 raised to the 4 equals 81. Now, you might say to me, is there a better way than just hunting down that 3? Instead of doing that, could we find something else to do? It almost feels like we're just doing trial and error. Well, to be honest with you, that's the best way to do these kinds of problems. You really do need to know those basic arithmetic facts, and you need to be able to do a good deal of mental arithmetic quickly in order to handle some of these problems very efficiently. Now, let's move to another example just to give us some practice with raising numbers to a fraction power. Let's find 125 raised to the 1/3 power. Okay, now just like the previous examples, we need to think a bit backwards. This time, we want a number which, when it's cubed or raised to the 3rd power, will give me 125. So what might that be? Well, what number might you guess could be multiplied with itself 3 times to give you an answer that ends in 5? Did you notice how 125 ends in 5? Well, how about the number 5 itself? Let's try it. If 125 raised to the 1/3 power equals 5, then that means, thinking backwards, that 5 to the 3, or 5 cubed, has to equal 125. So, is that true? Well, let's check it. 5 raised to the 3, or 5 cubed, is equal to 5 times 5 times 5, which is equal to 25 times 5, which is equal to 125. And that's perfect. So that work, and somewhat backwards work, shows me that 125 raised to the 1/3 power is equal to 5. Now, let's close with one more problem of this type, just to again get a feeling for the different things that can happen when you're working with raising numbers to a fractional power. Let's find the number negative 125 raised to the 1/3 power. Now, this problem should remind you of the example that we just did, but now there's a negative sign in front of that 125. Is that going to cause us trouble? Well, let's see. Can you think of a number which, when cubed, will give us negative 125? Well, we saw that 5 cubed equals positive 125. Let's use that information to our advantage here. Let's try to see if our answer to negative 125 raised to the 1/3 is negative 5. That would mean that we would need negative 5 raised to the 3 equals negative 125. Well, is that true? Let's see. Negative 5 raised to the 3 is the same as negative 5 times negative 5 times negative 5. Now, those first two negative 5's being multiplied together gives you positive 25. And so you can simplify that to positive 25 times negative 5. And 25 times negative 5 is negative 125, because a positive number times a negative number equals a negative. And that's exactly what we wanted, negative 125. So now I know that negative 125 raised to the 1/3 power really is negative 5, because negative 5 to the 3 equals negative 125. Now, I hear some of you saying, hey, wait a minute. We tried a problem a few minutes ago that had a negative number inside those parentheses, and it didn't have an answer at all. Why did it work here with the negative 125 raised to the 1/3? Well, I don't want to get too technical here, but the reason we can get an answer for negative 125 raised to the 1/3, but we can't get an answer for negative 49 raised to the 1/2, is that the denominator of 3 in the power 1/3 is odd, while the denominator of 2 in the power of 1/2 is even. Just for future reference, an odd denominator in the power works just fine with negative numbers down below, but even denominators in the power will not work if you have a negative number down below. And that's the difference between those two examples. Now, did you notice anything that all of those examples we just completed had in common? It's a little bit subtle, so you might not have seen it, but I'm hoping that some of you caught it. I want you to notice that all of the exponents in the examples we've done so far had a 1 in the numerator of the fraction in the exponent. So here's a question that we really should ask and answer in this lesson. What happens when that numerator in the exponent is something different from 1? That's a great question. I'm glad you asked it. So let's look now at a few examples of what you do when you raise a number to a fraction where the numerator is bigger than 1. Let's simplify 8 raised to the 2/3 power. Okay, this brings us to a very important rule about exponents, especially exponents that are fractions. So let me talk about this rule a bit, and then we'll look at this particular example. Here's how the rule looks when you're dealing specifically with fraction exponents. It looks like the following. When you want to raise a to the power b over c, it's the same as raising a to the b and then raising that to the 1 over c power. And it's also true that a raised to the b over c is the same as raising a to the 1 over c first and then raising that whole thing to the b power. Now, I can see some of you right now screaming, wait a minute, slow down. Well, I can understand that. It is kind of a scary looking rule at first. But let me show you what I mean with this rule by looking at this particular example with 8 raised to the 2/3 power. Here's what the rule tells me. It tells me that I can break up 8 to the 2/3 power as 8 to the 2, then raising that to the 1/3. That's perfectly fine. And it also tells me that 8 raised to the 2/3 power can be written in a different way, and that is as 8 to the 1/3 power all then raised to the 2, which is the numerator of that fraction. So I have two different ways that I can split up 8 to the 2/3 power, but both of them will give me the same answer. And I want to confirm that now by working out both of those things step by step to see if they both give me the same answer. So first, let's look at 8 raised to the 2/3 power as 8 to the 2, then raising that to the 1/3. Okay, how do I do that? Well, the 8 to the 2 that's down in the parentheses is going to give me 64. 8 squared is 64. And so I can rewrite things as 64 raised to the 1/3 power. And now if I think about it for a minute, what's a number that can be cubed to give me 64? You see how we have to work backwards again? Well, the answer is 4, because 4 times 4 times 4, which is 4 cubed, is the same as 16 times 4, which is 64. So 64 to the 1/3 is 4. So now let me be clear. That means that 8 to the 2/3 power equals 4. But now I want to try doing that 8 to the 2/3 power again in the different way, the other way, and make sure I get 4 from that approach as well. So let's do it here. I can also write 8 to the 2/3 power as 8 to the 1/3 and then raise that to the 2. That's very different from what we did a moment ago. And when I do that, I'm going to look for the 8 to the 1/3 first. 8 to the 1/3 is 2, because 2 cubed is 8. And that's going to give me 2 raised to the 2 power that was already sitting out there. And now I just need to figure out 2 to the 2nd power, or 2 squared. Well, 2 squared is 4. So what I see then is that I've gotten the same answer using either of these ways of rewriting 8 to the 2/3 power. So now the next very natural question to ask is, which of those two ways is the better way or the best way? Well, they're both perfectly fine, but it turns out that the second way is much smarter. And here's why. It's because the numbers that come up in the intermediate steps of the solution, the sort of middle steps of the solution, always stay smaller rather than get big. Do you see that 64 that came up in the first way of doing the problem? We never got a number anywhere close to 64 in the second way of doing the problem. All of our numbers that came up in the second way of doing the problem stayed small. So either way of doing the problem is fine. Mathematically speaking, they're both perfect. But in terms of keeping the numbers small, I always teach my students that the second way is much easier. Now, let's do a few more problems like this to make sure we have the idea down, where we raise a number to a fraction power where the numerator is something other than 1. Let's simplify 32 raised to the 3/5 power. Okay, now I'm going to write this problem as 32 raised to the 1/5, and then I'm going to raise that to the 3 using this cool rule that we saw just a few moments ago. So I'm doing 32 to the 1/5, and then I'm raising all of that to the numerator of 3 that was in the original problem, in the original exponent. Now let's work through the problem as it's written this way. I want to do what's in the parentheses first. That's the 32 to the 1/5 power. Now I have to think backwards. What number is going to be raised to the 5 to give me 32? Well, that's going to be 2. 32 to the 1/5 is going to be 2, because 2 to the 5 equals 32. So now the problem is rewritten as just 2 raised to the 3. Well, what is 2 to the 3rd power, folks? It's 8, because 2 to the 3 is 2 times 2 times 2, which is 4 times 2, which is 8. And so this somewhat ugly looking thing at the beginning, 32 raised to the 3/5 power, is actually just the number 8 written in a very disguised way. Now, just to convince you that that's the better way to do that problem, I want to start doing that problem with the other way that you can write it. I'm not going to finish it this way because when we get to the middle steps, they're going to look really, really nasty. But I want to at least show you what happens if you rewrite the problem in the other way, just so you can see why I think the way I did it first was best. We could have said that 32 raised to the 3/5 power equals 32 raised to the 3 and then raise all of that to the 1/5. Mathematically speaking, that's perfectly correct. Now, what is the 32 to the 3, 32 cubed? Well, it's the same as 32 times 32 times 32. Do you want to calculate that for us? Well, I know that you can, but do you want to? I say we have lots of other things to do with our lives than multiply 32 times 32 times 32. So if you're okay or happy with calculating 32 raised to the 3, then you can keep working the problem out this way, and you'll get 32,768. But now to finish the problem, you have to tell me what 32,768 raised to the 1/5 power is. You need to tell me the number which, when multiplied itself 5 times, is going to equal 32,768. Well, I wish you well as you're doing that. It's not going to be easy. In fact, I'm not sure I would want to have to do that. It turns out that the number is 8, which is what we found a moment ago. But seriously, why bring all of that work on ourselves? If you do the problem the way I originally did it, it's very straightforward to see the answer. If you do it this other way, it's okay to do it that way, but the work is going to be much more. Now, I'd like us to look at another example where we simplify a number raised to a fraction power, and here's the example I want us to look at. 81 raised to the 3/4 power. I'd like you to take a moment to see if you can simplify that one, and then we'll come back together. Now, we just need to work through the problem the way I've handled the others, and again, I'm going to suggest that we write 81 to the 3/4 power in a smart way. And that way would be to write it as 81 raised to the 1/4 power first, and then raise that to the 3 that was in the numerator of the original exponent. When you do that, you have to find the 81 to the 1/4 first. So you need to think about a number which, when raised to the 4 power, gives you 81. What would that be? Well, that would be 3, because 3 to the 4th is 81. And so 81 to the 1/4 cubed becomes just 3 cubed. And of course, 3 cubed is 27. And so 81 to the 3/4 power equals 27. That's the final answer. All right, I want to turn a corner now in our lesson to talk about a very different kind of exponent that can come up in these kinds of problems. And that would be those pesky negative exponents. Believe it or not, there's just one simple rule to keep in mind when dealing with negative exponents. For some reason, it causes some students lots of headaches, but it's just a very simple rule. And here's what the rule says. If you take a and raise it to the negative b power, it's the same as taking 1 divided by a to the positive b power. That's it. So let me work through several examples so you can see the idea with some numbers in mind as we use this rule for negative exponents. Here's the first example I want us to look at. Let's simplify 6 raised to the negative 2 power. Okay, notice here that there's a negative sign in the exponent. Notice that it's not down with the 6. If it was down with the 6, like if we were looking at negative 6 raised to the 2, then we would just be looking at negative 6 times negative 6, which equals 36. But that's not what we're doing here. That's a common mistake that some students make, but it's not what we're doing here. The negative is not down with the 6, it's up with the 2. Now, since the negative sign is in that exponent, I'm going to use the rule that I just mentioned to you a few moments ago. 6 raised to the negative 2 power is exactly the same as 1 over 6 raised to the positive 2 power. And now you just need to work with that fraction. 6 to the 2, or 6 squared, is the same as 6 times 6, which is 36. And so 1 over 6 squared is the same as 1 over 36. And that's the final answer. And note that we have a much different answer here. It's just a tiny fraction, 1 over 36. That's exactly what 6 to the negative 2 equals. Okay, let's look at a second example now with a negative exponent in mind. Let's simplify 5 raised to the negative 3 power. And I'm going to suggest that you work through this example yourself, just like the example we just did, and see if you can get the answer. Okay, again, I need to recognize that this is very different from something like -5 raised to the +3 power. That's a totally different kind of number. Here, the negative sign is in the exponent, so I know exactly what to do to handle that negative sign. 5 to the -3 power is the same as 1 over 5 to the +3 power. And now I focus on that denominator, the 5 to the 3. I just need to calculate that pretty quickly. 5 to the 3 is 5 times 5 times 5, which is 25 times 5, which is 125. And so 1 over 5 cubed is the same as 1 over 125, and that's my final answer. All right, now let's make things a little more complicated. Let's simplify -2 raised to the -4 power. Now, don't panic. I do see the two negative signs there, but we can handle them one at a time. First of all, keep in mind that those negative signs do not cancel each other out because one of the signs is up in the exponent and the other one is not. So they're not going to cancel. Something more complicated than that will happen. But if we walk through the problem step by step, we're going to be just fine. So here's how we do that. We have -2 raised to the -4 power. That -4 power is the first thing we're going to handle, and we're going to handle it by rewriting -2 to the -4 as 1 over the -2 to the +4. That's the exact same rule we've seen before. So now my answer is up to 1 over -2 to the +4. Now, what is -2 to the 4th power? Again, I'm focusing on that denominator for just a second. Well, -2 to the 4 is the same as -2 times -2 times -2 times -2. And that's the same as +4 times -2 times -2. Remember, those first two -2's will multiply together to give me a +4. Now I'm going to take the +4 times the next -2. That's -8. So my denominator is now -8 times -2. And -8 times -2 is +16. And so my final answer turns out to be a little fraction, 1 over 16. And it turns out that the final answer is positive. It is a small fraction, but it's a positive fraction. That is not a problem at all. We've walked through the steps, step by step, and we're perfectly fine with that final answer. So -2 raised to the -4 power is equal to 1 over 16. Now, I'd like to close our lesson today with one more example. It's a pretty significant one, so if it bugs you a bit, don't worry about it. But if you can understand all the steps in the problem we're about to do, then you're well on your way to having this material mastered. Here's what I want us to do. Simplify the number 27 raised to the -2/3 power. Now, what have I done to us? Well, I've given us a fraction exponent which has a numerator bigger than 1, and it's negative. Is that a problem? Absolutely not. Just watch as we work through the problem step by step. First, let's settle that negative sign in the exponent really quickly. We know how to do it. We just handled it in a few examples a few moments ago. Using that rule about negative exponents, we know that 27 to the -2/3 power is the same as 1 over 27 to the +2/3 power. So notice, we just got rid of that negative sign that was in the exponent. See, that one issue is now gone for us. So now we can just focus our attention on the denominator, which is 27 to the +2/3, and we can just work our way through that, keeping in mind that that's just the denominator of the final answer. Now, how do we handle 27 to the 2/3? Well, the smart way to do it, I claim, is to do 27 raised to the 1/3, and then we raise that to the 2, or square 27 to the 1/3. Now, 27 to the 1/3, that's a number which when cubed will give me 27. What number can you multiply with itself 3 times to get 27? Well, that number is going to be 3, because 3 times 3 times 3 is 27. And so my new fraction, my answer, is really just 1 over 3 squared, 1 over 3 to the 2. And of course, 3 to the 2, or 3 squared, is 9. And so my final answer here is simply 1/9. So what appeared to be pretty ugly at first, 27 to the negative 2/3 power, it's not so bad after all. It's just 1/9. It's a pretty straightforward thing. As long as you work through those steps, you'll be just fine. Now, in this lesson, we've handled some serious arithmetic involving exponents, which are fractions, sometimes positive fractions, and sometimes negative ones. Next time, we're going to turn a corner as we begin to talk a bit about some more visual or graphical mathematics.